Good morning, everyone. So I'm Vishal Chorsia. As you all know that in last class, we were discussing about basic concept of chemistry. So in basic concept chemistry, basically we discussed about atomic mass, molecular mass, and then we discussed one formula that is mole. So mole, I discussed mole was what? Mole was equal to mass divided by molecular mass. So we discussed about this formula, and then I told that I will discuss some questions also based on this. So first question is this: the weight of one molecule of a compound C60H122 is. What will be weight if you take only one molecule of this? So how will we do it? First, what we can do, see, they're asking about one molecule, mass of one molecule, and you know that is molecular mass. So what is molecular mass? Tell me, molecular mass. Molecular mass of C60H122 will be what? So 60 into 12 AMU plus AMU I am saying, okay, plus 122 into 1. Why 1? Because for hydrogen you know atomic mass is 1. Now what is this value? Tell me. 12 into 6 is what? 72. So 720 plus 122. What is this? 842. 842 AMU means atomic mass unit. 842 AMU. Now what you have to do, since in option every value is given in grams, so you have to convert it into grams. How will you convert? So 842 AMU you have gotten. 842 AMU you have gotten. So now you have to convert this into grams. So 842 into what is 1 AMU? 1 AMU is equal to 1.6 into 10 power minus 24 gram. And if you calculate it, okay, see, you can see 16 into 8 is what? 128. No. And then, so 128 approximately, okay, this will come approximately this 1.4 into 10 power minus 21. You have to calculate it, okay? You can calculate. So 1.4 into 10 power minus 21 gram will be the answer. Correct? So this question you all can do. Again, you can see the weight of one molecule. That means it will be very less mass, okay? Very less mass. And how we can calculate? That is, first to calculate molecular mass. That is 60 into 12. Why 12? Because carbon we are taking, okay? 16 into 12 plus 122 into 1. So it is 720 plus 122. It is 842 AMU. So 842 into 1.6 into 10 minus 24. If you calculate this value, it will come approximately this 1.4 into 10 minus 21 gram. So this is the question that came in neat. And now we will discuss second question. Correct? Are you getting? Okay. Okay, now let's discuss this question. At STP, the density of CCl4 vapors in gram per liter will be. So first thing that you should know, what is STP? So STP is standard temperature and pressure. Standard temperature and pressure. Standard pressure is what? 1 atm, 1 atmospheric pressure, and standard temperature is what? Standard temperature is 0 degrees Celsius. Correct? Now, this is standard temperature and pressure. And you should know at standard temperature and pressure, one more thing you should know, for any gas at STP, molar volume means volume of 1 mole of gas, will be 22.4 liter. This thing you should know, okay? This is your very good concept, okay? This thing you know, and sometimes you have to use this concept also. But what we have to do here, see, at STP, the density of CCl4 vapors in gram per liter will be. This thing you have to do, okay? How will you do? See, so first write this. Now, density they are asking. What is density? Density is mass by volume, correct? Mass by volume, correct? Mass of CCl4 divided by volume of CCl4. Thing is, what we have to do, see, at STP, the density of CCl4 vapors in gram per liter, and you know at STP what? At STP, you know, For 1 mole of gas, it is 22.4 liter, correct? For 1 mole of any gas at STP will be 22.4 liter. So what we have to do now? So 22.4 liter, 22.4 liter, and tell me for 1 mole what will be the mass? For 1 mole what will be the mass? For 1 mole mass is molar mass. So molar mass of CCl4 is what? Molar mass of CCl4 is what? So here you can write molar mass. Correct? And molar mass of CCl4 is what? Molar mass of CCl4 is 12 plus 4 into 35.5 divided by 22.4. Correct? Okay, now what we have to do? What we have to do now? 12 plus 4 into 35.5. So 12 plus, what is 35.5 into 4? See, 35.5 into 2 is what? 71, and into 2 is 142, I think. 142 divided by 22.4. So this value is 154 divided by 22.4. And if you calculate it, see, 22 into 7, you know it is 154. Since it is 22.4, denominator is little bit higher than 22. So low value will be little bit lower than 7, correct? So value will be 6.87, correct? So this is the answer. 6.87 is the correct answer here. Now, what we have to do after this, now what we will discuss now. Okay, tell me one more thing. If someone is saying in 1 centimeter cube, 1 centimeter cube, or sometimes we can write 1 cc also, 1 cc of CH4 gas at STP contains. Okay, then see, this may be the question, and then they may ask for number of molecules or something. Okay, so how we will do for this? See, so for that you should know what is 1 cc. What is 1 cubic centimeter? 1 cubic centimeter or 1 centimeter cube, it is equal to what? 1 ml. 1 ml, correct? 1 centimeter cube is equal to 1 ml. This thing you should know. This is very important. Okay, 1 centimeter cube is equal to 1 ml. So what they are saying, 1 centimeter cube of CH4 gas at STP. And you know, at STP, you know, in 1 mole there will be 22.4 liter, correct? 22.4 liter or 22,400 ml, correct? 20, because you know in 1 liter there will be 1000 ml. So 22,400 ml. Now what we have to do? So this 22,400 ml, tell me in 22,400 ml, how many molecules of CH4 will be there? So of course it will be, since it is 1 mole, so molecules will be what? Avogadro number, 6.02 into 10 power 23 molecules of CH4 gas, correct? Now this is in 22,400 ml. What I am asking in 1 ml, so it will be what? 6.02 into 10 power 23 divided by 22,400 molecules of CH4. So this is the answer, correct? This will be your final answer. So this many molecules, and then someone may ask number of atoms. See, after calculating molecules, you know in 1 molecule there will be 5 atoms. So here you have to multiply by 5, correct? 5 into 6.02 into 10 power 23 divided by 22,500 atoms of CH4. Okay, atoms, correct? Now what we will discuss now? See, we have discussed atomic mass, molecular mass, average atomic mass also we have discussed, but we didn't discuss much questions. That we will discuss now, and after that we will start limiting reagent. Okay. Okay, so if you see this question, so boron has two isotopes, 10 boron and 11 boron. Okay, for one mass number is 10, for second isotope it is 11. So what will be average atomic weight? Okay, what will be average atomic weight? I told you whatever mass is given, multiply by that percentage. So 10 into 19 plus 11 into 81 and divided by. Now, since we are calculating atomic mass, atomic weight, correct? So we cannot divide. See, here mass is there and mass is there and percentage is there. We cannot divide by mass. Okay. Otherwise, unit will be different. So what we have to do now? 19 plus 81, correct? And you know 19 plus 81 is what? 100. So 10 into 19 is what? 190 plus what is 11 into 81? So 11 into 1 is 11 and okay. So in this way if you calculate and you will get some answer like 10.8. Here answer that you will get will be 10.8. Okay. And one more way, one shortcut is there for this. Okay. There is no need of doing all this calculation. So 10.8, I think this calculation is right. Okay. So 10.8 is the correct answer here. One shortcut is if you see mass number, when mass number is 10, percentage is only 19%. Okay. Mass number is 11, percentage is 81%. Means this is 81% and this is 19%. So mass should be approximately 11. No, because this is more in amount. Although it will be less than, because some amount of 10 boron is also there. Although it will be less than 11, but it will be very higher than 10. So it will be more than 10.5 and less than 11. So it is what? 10.8 only. See, 11.2 can never be the answer. See, why? Because when mass is high, boron 11, even if it will be 100% also, then also mass, average atomic mass can be 11. It cannot be more than 11. And it cannot be 10 also. Why? Because 10 boron is 19% only. Correct? We are taking mixture of this. And since this is higher in amount, 81%, so value will be approximately 11, that is 10.8. Correct? There is no need of doing this. Thank you. Okay. You can write this. Now let's discuss limiting reagent concept. So you all might be knowing from your 9th and 10th standard class that how to balance any chemical equation. Okay. So first that we are going to discuss is limiting reagent. Okay, limiting reagent we are going to discuss now. Okay, can you balance? Okay, do you know what will happen if sodium reacts with water? When sodium reacts with water, what will happen? See, sodium is here plus water. It will give you sodium hydroxide plus H2 gas. Correct? And some heat will be liberated. Now, question is, can you please balance this chemical equation? See, in mole concept, in stoichiometry, you should know. Stoichiometry, you should know how to balance chemical equation. Then only you can do these type questions. Okay. Whenever in mole concept, in basic chemistry, basically mole concept very important. And whenever someone is asking a question from here, you should know how to balance this chemical equation. Okay. So first is one sodium and here one oxygen, two hydrogen. Okay. Here only one oxygen and three hydrogen. So here is three hydrogen. Here is two hydrogen. What we will do? 2 NaOH. Now 2 hydrogen plus 2 hydrogen is 4 hydrogen. So here 2 water and now 2 sodium also. Correct? This is balanced chemical equation. Now what we have to do to get the concept of limiting reagent. What is the meaning of limiting reagent? As name suggests, reagent that will limit the chemical equation. That will limit the chemical process. How will it limit? That thing we will discuss. Okay, tell me. See, this means, this stoichiometry means mole. Okay, mole. 2 mole. This is 2 mole. This is 2 mole. And this is what? If there is nothing written, then it is 1. Okay. If nothing is written, then it is 1. For 2 mole of sodium, 2 mole of water is required. Okay. If 2 mole of sodium is there, then 2 mole of water is required to get 2 mole of sodium hydroxide and 1 mole of hydrogen gas. Correct? This is the meaning of this. Now, so 2 mole of sodium is required and 2 mole of water is required to get 2 mole of sodium hydroxide and 1 mole of H2. Correct? Now, what will happen? Let's say now actual case is what? You're taking 2 mole of sodium, but you're taking only 1 mole of water. So which one is limiting reagent? 2 mole of sodium you're taking and 1 mole of water is taking. From your balanced chemical equation, you can see for 2 mole is required. Okay. For 2 mole of sodium, 2 mole of water is required, but you are taking only 1 mole. Correct? So this water is your limiting reagent. Means after some time water will not be there, so reaction will not happen. That means because of water only reaction got stopped. Correct? That means water is a limiting reagent. But see, here it is 1 mole, here is 2 mole. Since for 2 mole was required, but we are taking only 1 mole of water, so water is limiting reagent. So which one is excess reagent? Because some sodium amount will be there, some 1 mole will be remaining. No, so that is excess reagent. So this sodium here is excess reagent. Correct? Excess reagent. And water here is limiting reagent. Limiting reagent. Correct? So since we are taking only 1 mole, so 1 mole of water will require how many mole of sodium? Only 1 mole of sodium. So 1 mole will be remaining. That is 1 mole excess reagent will be remaining. So only 1 mole of product you will get. Correct or not? See, for 2 mole of water you will get 2 mole of sodium hydroxide. But since you are taking only 1 mole of water, so you will get 1 mole of sodium hydroxide. Correct? 1 mole of sodium hydroxide you will get. Correct or not? Okay, now what we have to do, we will see some more equation. Okay, yes. So now let's see some more question. For example, formation of water from hydrogen and oxygen gas. H2 plus O2 will give you what? H2O. Question is, can you balance this chemical equation? See, how many hydrogen is here? 2 hydrogen. How many hydrogen here? 2 hydrogen. Here 2 oxygen, while here only 1 oxygen. So you have to multiply by 2. Correct? Now, is it balanced chemical equation? Yes. See, 2 hydrogen, 2 oxygen, and here is, okay, here is 4 hydrogen. So here also you have to multiply by 2. So now 4 hydrogen you are having, 2 oxygen, and here also in right hand side also same thing you are having. This is balanced chemical equation. Now from here you can see 2 mole of hydrogen requires 1 mole of oxygen to give 2 mole of water. Correct? Now what we will do, we will take 2 mole of hydrogen, okay, 2 mole of hydrogen and 1.5 mole of oxygen. Correct? Now tell me which one is limiting reagent. I told you, okay, first step should be, first you write balanced chemical equation, and then from that balanced chemical equation you say, okay, you have to think, see here 2 mole is there, here 1 mole is there. That means for 2 mole of hydrogen only 1 mole of oxygen is required. If you will take more than this, it will be excess reagent. If you take more than 1, it will be excess reagent. If you take less than 1, it will be limiting reagent. Correct or not? It's very simple. See, here you are taking 2 mole of hydrogen, while here you are taking 1.5 mole of oxygen. Correct or not? Required, see, although it is less in number of moles, if you compare with this, it is less in number of moles, but this is not limiting reagent. Okay, limiting reagent means from balanced chemical equation you have to compare. For 2 mole of H2, 1 mole of O2 was required, but you're taking 1.5 mole. Correct? Or for 1 mole of oxygen, 2 mole of H2 is required. Correct? For 1 mole of oxygen, 2 mole of H2 is required. Correct or not? Means just twice is required. Here also for 1.5, 3 mole of H2 is required, not 2 mole. So this is your limiting reagent. Correct? This one is limiting reagent. Limiting reagent. And this one is, this is O2 is your excess reagent. O2 is excess reagent. So what I want to convey is, although this is less in number of moles, but this is not limiting reagent. Why? Because for 2 mole of H2, 1 mole of O2 was required, just half amount, half number of moles. Here we are taking more than 1. That simply means it is excess. It is in excess. Means for 2 mole of H2, only 1 mole of O2 is required. So 0.5 mole is in excess. So 0.5 mole of O2 will be in excess. Means 2 mole of H2 will take only 1 mole of O2 and 0.5 will be remaining in the beaker. Okay, so 0.5 will be in the excess. Correct? Now, some more question also, because this is very important concept. Okay, if you don't know this, then you cannot do questions. Okay, some more questions, some more concept we will see based on limiting reagent only. Now let's take one more example that is very important, that is N2 plus 3H2 will give you what? 2NH3, correct? N2 plus, this is formation of ammonia. You know what is this process? Haber process. Now, is it balanced chemical equation? Yes. 1 mole of N2, 3 mole of H2 will give you 2 mole of ammonia, correct? Now, let's say we are taking 1 mole of N2, okay, 2 mole of H2. Now you tell me which one is limiting reagent. I told you, don't say this. Do not say that since it is less in amount or it is more in amount. No. First you have to compare with this. Okay. So although it is less in amount, but then also it is in excess. You know why? Because you know, for 1 mole of N2, 3 mole of H2 is required, correct? For 1 mole of N2, 3 mole of H2 is required, but we are taking only 2 mole. We are not taking 3 mole. It is less than 3. No, it is less than 3. So this one is what? This one is limiting reagent. This one is limiting reagent. Correct? So what will be this then? This will be in excess reagent. Excess reagent. Means here H2 will stop the reaction. Because of H2, reaction will get stopped. That means H2 will decide the number of moles of product also, okay? Or number of moles of N2 consumed. Everything H2 will decide, because H2 is in limit. H2 is in very less in amount if you compare with balanced chemical equation. So here, you know, for 3 mole of H2, 1 mole of N2 is required, just 1/3, okay? Just 1/3. So for 2 mole of H2, how many moles of N2 is required? So it is 2/3, correct? For 1, okay, for 3 mole, okay, you can write like this. For 3 mole of H2, 1 mole of N2 is required, okay? So for 3 mole of H2, 1 mole of N2 is required, correct? So for 2 mole, how much will be required? Tell me. Let's say it is X mole is required. So X is what? X is what? Cross multiply. So X is 2/3. Only 2/3 mole of N2 is required, but we are taking more than 2/3. It is 1 mole we are taking. That means something will be left in that beaker, in the system, okay? So excess amount, excess number of moles of N2 gas will be 1, because 1 we have taken and we have used only 2/3. Only 2/3 amount we have used. So 1 minus 2/3. So this is in excess. So 1/3 will be in the beaker. While limiting reagent will be 0. There will not be any limiting reagent after the completion of the reaction. Correct or not? And how many moles of ammonia will get? Tell me. See, we are taking 2 moles. This is limiting reagent. So this will decide the product. See, 3 mole was giving you. Okay. Now someone may ask, number of moles, okay, number of moles of ammonia formed will be equal to what? Okay, and you have taken here, you have taken 1 mole, here you have taken 2 mole, correct? You know 3 mole of, okay, this is limiting reagent, I told you. 3 mole of H2 are giving you 2 mole of ammonia. So 3 mole will give you 2 mole of ammonia, and you are taking 2 mole of H2. So it will give you X mole of ammonia. All that is very common sense, okay? So just cross multiply, you will get what? 3x equal to 4. X is 4/3 mole of ammonia. This is the answer. 4/3 mole of ammonia you will get from this process. Correct? If there is any mistake I am doing, then you can correct me, okay? So 4/3 mole of ammonia you will get in this process. Now, we will do some more questions. Okay, so as we have discussed the concept of limiting reason, now we will utilize this question. How will we do this type of questions? So first I told step 1 is write down balanced chemical equation. Okay, how will we write? First reactant is H2, second is Cl2, correct? You all can read this question first, okay? So H2 plus Cl2 you are taking, okay? So H2 and so H2 you are taking plus Cl2. So what will be the product, tell me? So product will be 2HCl. 2HCl. This is balanced chemical equation, okay? Now, so 1 mole of H2 with 1 mole of Cl2 will give you 2 mole of HCl, correct or not? We are taking 22.4 liter, 22.4 liter of H2 and 11.2 liter of Cl2, correct? Now, can you please tell me number of moles here for this? You know, in 1 mole I told you at STP for any gas, for 1 mole is 22.4 liters. So this is 1 mole. So this will be what? 0.5 mole. Now you apply the concept of limiting reagent. You know, for okay, 1 mole, for 1 mole of Cl2 is required and you are taking only 0.5 mole. So this is your limiting reagent. So this will decide the product of HCl. So okay, 1 mole is giving you 2 mole of HCl. So 0.5 mole will give you what? See, it is twice. No, it is twice. So here also it will be twice. So it will be 1 mole of HCl. So this will be your answer. Correct or not? So 1 mole of HCl. So first step is write down balanced chemical equation. Second step is find out number of moles. Then decide limiting reagent, and from limiting reagent you have to decide number of moles of product. That's it. Okay, thank you.